Hello and welcome to another tutorial. We're going to continue our discussion on native image and compiling the Java applications to native executable files. And I'm going to discuss a very important and also very interesting topic of how to handle Java resources when we are compiling a Java application to native executable binary. Now, sometimes at compile time, we need our source file needs to load some resources. And then when we run our Java applications, obviously JVM handles those kind of resources. But then how does it work when we actually want to statically compile the application to executable files? How do we ensure that those resources are correctly taken care of? So a resource is data, images, audio, text, and so on. And in this particular lecture, I'm going to focus on the text resources, basically text files that a Java program needs to access. Resources can be included in Java archives, jar, as well. Basically, when you package your application, if there is, let's say, a text file or some sort of CSV file that has some data and your application really requires those to be available, right? When you launch your application, it has to read some stuff from a text file or a CSV file. You can always also include them in the Java archives or jar, because when you work on your Java project, eventually the goal is to package it in some format like jar and then distribute it as the binaries like jar. So jar has all the binaries of your Java application, which are all the class files, but then you want to also bundle all the resources, all the files that your application also needs into that jar archive. And obviously, in order for the packaging to successfully bundle them, these resources should be on the class path at compile time, right? Maybe not. It's not the job of the compiler to handle resources. There is a tool called the jar that comes with the JDK. It's a command line tool, and that can handle packaging your Java, right? And again, you have to specify the class path for that, and on the class path those resources should be available. So if I open up a new terminal here, I have JDK 17 from Oracle on my path. So Java -- version, we have the JDK 17, and one of the tools is jar -- version. It's jar 17 for JDK 17. And if we just look at the help menu, --help, and then as you can see, it has, so the job of the jar is you give it your application, the class path, and then it bundles them into a Java archive. So jar -- create is for creating an archive, and then you can specify the name of the jar and then all the classes that you want to bundle, and then you want to also specify a manifest. Again, if you're not familiar, manifest usually has extra information for runtime. For example, what is the class path when the JVM tries to load the jar, how the class path should look like for all the files and packages that are inside the jar. Jar -- create file footer jar. So this is you specify the name of the output, -- main class if you are creating a executable jar. And then if you want to also add module information, you can do that. And then you see after the classes, you can also specify the resources that can be bundled into the jar file. And so if you already have created a jar and then you just want to update it with more classes, you can use the -- update. So if you're working on a very large project and you don't want to run the jar on all the classes all the time, some classes might not change, maybe later on you just want to add basically one more class, then you can just update the currently available jar. And then you see there are some also options. -c or -- creates the jar. -i or generate index creates index about which classes packages are there. -list table of contents. -- update. If you want to unarchive a jar file, you can use -- extract, and this just extracts the I believe it extracts, there's only like class files, binary files that this extract that. -- describe module -- validate. And so as you can see, in basically not only you can package classes, you can also add manifest, and then you can also add resources. So resources can be bundled with your application if your application really requires some resources to be available. So about the text file, we cannot directly access resources in a jar file using the file class. Now, obviously, when we say resource and accessing a file, your first thought should go to the file class that comes with a Java IO package, right? And file is an abstraction of the operating system. Remember, operating system terminals, they understand files, right? File paths, file permissions, we discussed all of these concepts before. But then Java is all about abstraction. Java wants to everybody to on any possible platform like Windows, Mac OS, Intel CPU, AMD CPU, ARM CPU. Java wants everybody to use the same API for handling this kind of stuff. That's why file is more like an abstraction of the underlying operating system file system. Different operating systems have managed the files differently. Remember, a file or data on a permanent storage device like a hard disk, it's just to a computer, to a machine, it's just zeros and ones, right? The way that the operating system interprets them gives them actual meaning that the humans understand, right? But under the hood, it's just zeros and ones, a sequence of bytes. And you might be already familiar that Java provides byte streams, right? Streams, input stream and output stream. Same with even C++ APIs, right? They all handle files in a stream of bytes, more like sequential access. I believe you can't really access a file in a parallel way because it's just the limitations that the operating system have on how to access the files. So a file class that the Java provides in the Java IO package. So I'm going to write it Java IO package. File class is an abstraction of the underlying operating system OS file system. You don't care about if you're using Linux, it uses its own file system. Mac OS uses its own file system. Windows, NTFS, right? It uses its own file system. Different operating systems use their own file system. Let's focus on a file that has textual context or content or characters. Again, characters don't have any meaning to a machine, to the hardware, right? Characters are just sequences of zeros and ones, like any other data. What gives them meaning? The way the applications that we write interpret those sequences of bytes. That's why we have encodings like UTF-8, UTF-16, etc. What this means, again, if you're not familiar, I'm going to give you a quick explanation. Encoding means you look at the content of a text file, right? Or any file, doesn't matter. It doesn't have to end with txt file or any kind of file, right? And then what happens here is that you start reading all the contents in the sequence of bytes. And then if the contents represent text, then based on the encoding you choose, let's say you choose UTF-8, which means every 8 bit or every 1 byte translates or maps to a character. And then the applications, the softwares that we use, read those bytes, and on the display they show those characters, right? Really, literally, the concept of fonts. Every operating system has a font library, and then based on the characters, it can display like every pixel on the screen so that that character is shown, right? So eventually, the job of the applications and the operating system together is read those bytes, translate them or map them to characters, and light up pixels on the screen based on the font library that you choose, that the application chooses, so that you see the correct characters. And Java, I believe, uses UTF-16 internally for translating basically characters or streams of bytes into characters. All right, so we can use the scanner class to read the text file. Again, if you're not familiar with the scanner, I highly recommend that you get to know it. It's a very, very versatile class, which especially in the most recent versions of the JDK, it's very handy, very useful. Basically, whenever you want to read some text, not just from the file, you will see that I will show you examples like from anywhere, even from the terminal, right? If your application wants to get some inputs from the user in the format of text. I mentioned before that terminal is just a textual application. It's a GUI, graphical interface, that only works as a text, right? Everything that the user inputs to the terminal, it's just a string, right? So a scanner is a very versatile class. Let's say we have a text file and we want to read its contents and then bring those content into our application. Then we use a scanner class, and it's in the Java util, right? It's from Java util package. and then it's a very powerful class for dealing with reading and tokenizing text. So a scanner reads the text, which means it reads a file. You give it a file, and then it reads it byte by byte, or based on the default character encoding of the platform, right? So when you install Java, JVM knows the default encoding platform, and then it reads and tokenizes. Tokenizing means if you have like a stream of characters, there's always a white space that it's delimiting. It's a delimiter or indicator of where a word starts and where a word ends, right? Obviously, if we have a word that has multiple parts, we usually use hyphens, so we don't have a space to say that it's a one word. Whenever you have white space, it means you definitely have two words. So the scanner tokenizes them based on the white spaces, and then you can ask a scanner to print them to the console, etc. So the path, relative or absolute, should be passed to a scanner class as a file. So if you look at the constructor of the scanner, it has a huge number of constructors. You can give it a file, so that tell it, hey, a scanner, go access the contents of this file, read them, and then encode them as characters, right? Remember, a scanner is all about text. Or you can tell it input a stream. Instead of telling the scanner, hey, go, instead of giving it a file, give it an input a stream. Again, a stream means it's a sequence of bytes, and then a scanner again reads those bytes, and based on the encoding, the character encoding, it translates them into characters. Path, I believe it's a more recent concept than the file, but it's more or less the same story. Path means, hey, there is a text there, text file, and in this path, and then go access it. Readable, anything that readable, anything that can be read, you can also do that. Readable byte channel, again, a scanner, we feed a scanner bytes, or a string. And in the old versions of the JDK, if this string was actually a path to a file, then a scanner could access it, but they actually removed that functionality. So when you give a scanner, the constructor of the scanner, a string, it actually tokenizes that exactly that string. So it's not accessing the file based on this string as a file path. So if you want a scanner to access a file, you have to use a file object. And the other parts are the same, the other construct the same, but then you can also provide a character set, how a scanner translates those bytes that it reads to characters. So you can provide, I believe by default, obviously the constructors that don't have this character set, they use the default platform character encoding, which most likely is going to be UTF-8. Or you can provide the name of the character set or character encoding as a string, char set, and all the ones, right? So the constructors that don't take a char set, and the constructors that also take a character set or the encoding. All right, so let's head to Eclipse and try to first of all access a text file and read the context using a scanner, and then we come back, look at the next slide to see how we're going to handle Java resources like a text file, how to embed it actually in the native image that we compile and build. So inside this Eclipse, I create this class resource demo. I have this very simple runme.sh. Again, extensions don't have that much meaning. It's just the because any file, regardless of its extension, is a binary file. The contents on the hard disk are saved as zeros and ones. So when I double click on this, this tab pops up. This is a plugin, right, that Eclipse has that reads the context, and then if it tries to display them as text file, right, tries to use the UTF-8 encoding or whatever default encoding that Eclipse uses to convert those binaries into text file. So let's say I want to read the contents of this file. So again, it's something that I want to read, so I immediately go and create a scanner, new scanner. And then I want to read from a file. So if I use a string and tell it the path to this file, relative path. So when I run my Java application using Eclipse, it sets the working directory to the project root, and my file runme.sh in the project root. So I can say from wherever you run your application, runme.sh. All right. And then a scanner follows the iterator pattern. So we can say while a scanner has next, we're going to print sysout scanner.next. which whenever a scanner reads, obviously a scanner also provides some buffering, which is good because buffering helps speeding up the process, because usually accessing the file, accessing a data on a hard disk is the bottleneck, right? If the data is already in the RAM, random access memory, the access is going to be fast. The fastest access is obviously when the data is actually in the cache of the CPU. It's very close, right? So from the cache to the RAM to the hard disk, these are where the bottlenecks start to show up. But here we are, when a scanner reads the this text, it's going to tokenize it. So if we run these, you might be surprised that you were hoping to access the contents of this file, but it's not the case anymore. So when you pass a string, a scanner actually tokenizes the string itself. That string becomes the source of the textual content. For example, if I say, hello, how are you doing, right? And if I run it, you actually see that a scanner tokenizes this string itself, right? So you cannot pass a string that contains a path to a file, and a scanner won't work. So you have to pass a file, new file, and then a string path to the file class, which is an abstraction of the underlying file system of the operating system. Now you can tell it run me.sh. Obviously, when you're accessing the file, the file might not exist, the name might be wrong, so you have to handle that file not found exception. All right, so let's run this. Now we are accessing the contents of this file word by word, because this next method goes word by word. We can also read line by line, so has next line. Again, a scanner is a very powerful iterator. So next line. You can also directly read numbers, integers, double float. So if I run this, it just reads the first line and then terminates, right? So that's how we are accessing textual contents. So if we use another constructor of a scanner that asks us for the character encoding, so we have file, and then we can say charset, which comes from Java NIO dot default for name class available charsets. It creates a map. So let's first look at the available charsets, right, or character encodings. Let's available charsets, and then it's a sorted map. So we can say available charsets for each, and then for key and value pairs, we're going to do a sysout. Basically, key goes to value, and then dot formatted k and v. Let's see what we get here. So you see there are lots of different character encodings. One of them should be UTF-8. Obviously, one of them is going to be UTF-16. UTF-16, basically BE and LE, Little Endian, something like that, I believe. Or these are something. So these are extensions of UTF-16, UTF-32. And Windows encodings, and then other encodings. So Java supports lots of different encodings. So let's see what happens if we run our scanner. But then we're going to use the available charsets and then get, it's a map, and then we're going to say UTF-8, which I believe it's going to be so it has the IO exceptions. Let's see what exception we're going to handle. It's just IO exception. So when you pass the file, it uses file not found exception, but this constructor throws IO exception. So it's not just the file. So let's run this. Cannot invoke charset new because charset is null. That's interesting. So let's see UTF-8. Do we have a dash here? UTF, yeah, we have to use a dash. So UTF-8. So let's also comment this print. Yeah, we are still doing. What if we change the character encoding to UTF-16? Now we're kind of not seeing anything. What if UTF-8, UTF-32? Still nothing. So UTF-8 works because that text file was created with UTF-X encoding, right? Which is, I believe, the default encoding of the macOS operating system. But if we print this more, let's see, let's try another thing. ISO 8859, something like this. Let's see what we get now. This still works fine. Interestingly, yeah, Java-version. So, I mean, if you know that your particular text file has a very specific encoding, you can directly use it in the scanner class, right? And then you can also access, as I mentioned before, you can also access, for example, in a scanner is very versatile in the sense that you can hook it up not only to files or feed it directly a string, you can also hook it up to streams, for example, system.in. And we've used this before. Oh, by the way, Eclipse compiler complains that a scanner is consuming a resource, so it has to be closed. And I've mentioned this before, that whenever you hook up the scanner to the system input, you don't really need to close it, because system, as soon as you run your Java application, the system in is always open. That's the input stream that is always open, and it doesn't close up until you terminate your Java application. So basically we can read something, and then so let's run this. So we feed this some information, hello, how are you doing, and then it prints it to the console, and then we can say something else. So the system in is always open and it's always listening, new input, and then a scanner is also always listening. A scanner listens to this input stream. Whenever there are some bytes available, it reads them and then translate them into character. All right, so this was the introduction to this string. Now, what I would like to this was the introduction to the scanner. What I would like to quickly show before ending this lecture is that we're going to give the new file, and it was runme.sh. Let's also remove the unnecessary imports. If you run this is going to work fine. And then if I select this class and try to compile it to the native executable, what you will see that obviously the compiler succeeds, because the static compiler of the native image doesn't care what this is, right? This string, it doesn't care. It just cares that you're accessing a file. So that's fine. It says, okay, that file should be available at runtime after the compilation succeeds. So you will see that the compilation succeeds, but obviously when we run the file, things are not going to work that well, because first of all, in our source code, we're using a relative path. And this relative path will cause some problem. The other thing is that even if we use an absolute path to this file, runme.sh, if when I compile, that absolute path is hard-coded in the source file, if I give it to some other person on some other computer, if they run it, the application will crash, because that hard-coded file is specific to my directories, right? So we have this compiled file. If I run this, I say resource demo, it's going to fail because file not found exception, right? Because I said you're running your Java application, and in the binary of this application there is this .runme.sh. What this means is that we're using a relative path. So if I try to go one level up, I'm in the root of my project and try to say native Java. If I run this works fine. Why? Because now in this binary, it tries to search from the current working directory, which is now here, because we use dot in this string, and tries to find a file that called runme.sh, and that file now exists in this working directory, this runme.sh, right? So now the application succeeds, and you see the problem here. We use Java to be platform independent. But now that when we compile to the native executable file, that hard-coded name of file is problematic, because first of all, it depends where we run it from, right? If we use a relative path in our source file, then you have to run your Java application really from from a specific working directory to make it work. If I go anywhere else, let's say go into this app directory and then try to say that, okay, go one level up, go into the native directory and run this. This is going to fail because, again, this ./runme.sh means from wherever you run this binary, executable binary, there should be a file in the same working directory called runme.sh. And obviously in this app directory, there is no such file, right? So we want to write a Java code that is platform independent, which means we don't want to tie ourselves to a particular hard-coded file name. Instead, we want the JVM to somehow locate that resource when we run our Java application. Because once that happens, the native image has a compact version of the JVM inside. So once our Java code is independent of it's not directly tied to the file system of the platform, and it somehow can dynamically locate the resources, then when we compile to the native executable file, then there shouldn't be any problem, right? So this is a topic of the next lecture. I hope you enjoyed this one. Please stay tuned, and I'll see you in the next one.